Hello, this is Jack Jackson. In this video, we're going to do another application starting with the PDF formula just to give us a little bit more practice. After watching the last video, you should know how to do this one. So let's see if you can do this one. I'll ask you to pause and check some work as you go along the way. Okay, so here's the formula for a PDF. Somewhat complicated formula. PDF of x is 1 over the square root of 2 pi times e to the power negative x squared over 2. So get this in, graph the PDF in an appropriate window, and it actually goes from negative infinity to infinity. But if you use negative 10 instead of negative infinity and 10 in place of infinity throughout on the TI-84, this, or actually even in the Inspire, this actually works out pretty well for this particular exercise. So get this in, graph the PDF, and verify that it is a legit PDF. Okay, press pause now. Okay, now you're back. So if you did here it is on the Inspire, and then I'll do it on the next screen on a TI-84. So I put my formula in this. I just stored it as PDF of x. I stored negative infinity as L. And I can actually use negative infinity there. And actually negative 10 actually in this one actually works better because the approximation will come out to be 1 exactly if I go from negative 10 to 10. Whereas the approximation technique, it doesn't work quite as well from negative infinity to infinity. But this area does come out to be 1, so that's one condition. And of course the other condition is when you graph it, the graph is always above or on the x-axis. And I graphed it from negative 5 to 5 here, and you can look and see there. And then the y's from 0, well, I went a little below, from negative 0.1 to 0.5 actually gets all of it. And so we get a curve. Several of our curves look something like this. This is something that we've seen before. Okay, so here it is on the TI-84 if you had that. So we'll get back to y2. Right now, just turn it off. For y1, I put in 1 divided by square root of 2 pi e to the power negative x squared over 2. Pretty much how it looks. That is the new operating system. The older one looks a little bit different. You have to be a little bit more careful of your parentheses. Be sure you put the under the square root part in parentheses. Be sure you put the power in parentheses. But then otherwise that works pretty well. And you graph it, you get this. And so if you do integrate math 9 from negative 10 to 10, you see it turns out to be 1. This is a newer operating system, looks like that. The older one over here. Again, I use the same window, and there's more or less the same graph. Not quite as pretty as the Inspire, but still just as effective. Next, compute and illustrate the probability that x is between negative 2 and 2. Press pause now. Well, if you just need to compute it, you can do it from the home screen. You're integrating or summing up the probability. Probability is in y1, the PDF, and you're summing that up from negative 2 to 2. You're doing that integral, which is about 0.95 something, about 95%. If you do it the older operating system, that looks like this. So again, that's math 9, and then put in y1 of x, or just y1 is okay. Leave out the of x if you want, comma x, comma negative 2, comma 2, close parentheses, or do it this way. Again, you can just put y1 instead of y1 of x if you'd rather. To shade it, you want to do a calc, which is second trace, and choose number 7. It's asking for a lower limit, put in negative 2, enter, upper limit, put in 2, enter, and then it shades it and calculates. Remember to clear draw by doing second program 1, enter, and then make sure that you clear the drawing when you're done. But that area there is the probability we're looking for. You can do the same thing here on an Inspire. You just integrate negative 2 to 2. Our formula is in PDF of x, and there it is, the same number. On the graph, go to the graphing tab, and then do menu. Number 6, analyze graph. Number 7, integral. When asked for lower bound, type in negative 2, enter, then 2, enter for the upper bound, and it shades it and computes the probability. Right now I have mine set showing 4 decimal places here, but a lot's here. Find an A value where the probability that x is less than A is 0.2. Now this is an inverse probability. We need a CDF for this. Okay, so here's where we need to use the CDF. See if you can remember how to do this from before. Press it, pause. Okay, well, what you do is you have this set up as function integrate y1 of x from L to x, or on the newer operating system, it's set up as an integral. I think we actually saw that picture earlier. Yeah, here it is right there. Okay, so here it is. Here's what you do. You need to turn that one on. I don't have the right one turned on over here, but you turn that on. You also put in 0.2 on this one as well. And then you graph it. Now, you need to have the right number stored as L, and I told you to use for the lower, which should be negative infinity, but we're going to use negative 10 instead. I cleared my drawing, if anything I had on there before first. Graph it. Graph y2 and y3. Set up y3 like that. And then calculate an intersection. It may graph slowly, but eventually you can get it to be this, negative 0.84. You can do the same thing on the Inspire like that and work it out. You can also work it out on the Inspire with a solve. Okay, so there's a good example of how we can use that. So notice that the only reason we really needed the CDF, other than just to see it, was to find the inverse probabilities, and then we needed to use this little special technique for doing that. For my class, you'll have some problems, like at least one problem like this on the homework set, but you won't have problems where you actually have to do all this stuff here on the exam. For one reason, because it locks your calculator up for a little while, and just to save time.